Hi students, I am Awais Ahmed Hussaini, working as Assistant Professor in Mechanical Engineering Department at Sharad Institute of Technology, College of Engineering, Yadra. In our earlier video, we discussed the fundamental concept of the thermodynamics related with that applied thermodynamics 1. In this particular video, we will discuss different laws of thermodynamics and different gas laws which is related with that thermodynamics, and definitely both concepts definitely will help you to clear your basic concepts of the applied thermodynamics 1. So let us start with the zeroth law of the thermodynamics. So this zeroth law deals with the concept of the equilibrium. So what is exactly that equilibrium? Equilibrium is nothing but the balancing. There are three types of the equilibrium: mechanical equilibrium, chemical equilibrium, and thermal equilibrium. But here we need the concept of the thermal equilibrium in order to study the zeroth law of thermodynamics. Let us start with the example of one rod. We just take example of one rod which is heated from one end. So in this particular case, we can imagine that the heat is always transferred from high temperature region to lower temperature region. But after some time, equilibrium condition arises. At that time, we say to fail, heat is always transferred from high temperature region to low temperature region. During that equilibrium process, there is no any kind of the heat transfer takes place. So this particular law deals with the concept of the equilibrium. The zeroth law of thermodynamics states that if two thermodynamic systems are in thermal equilibrium with the third one, then definitely that first and third one will be thermal equilibrium with each other. So here, if A is thermally equilibrium with B and then A is thermal equilibrium with C, then definitely that B and C are thermal equilibrium with each other. So there is no any common sense behind it. So this law is totally depends on the concept of the common sense. So this is the zeroth law of thermodynamics. Now we will discuss the concept of the first law of thermodynamics. Keep in mind that the first law of thermodynamics is related with the transformation of the energy. So here the first law states that energy is neither be created nor be destroyed, but it can be transferred from one form to another form. So this is the first statement of the thermodynamic. I repeat once again. Energy neither be created nor be destroyed. It can transform from one form to another form. So this is the statement of the first law of thermodynamics. Another statement of the first law of thermodynamics is cyclic integral of the heat transfer is exactly equal to the cyclic integral of work transfer. So the meaning is Q is equal to W. I repeat once again, the second statement of the first law of thermodynamics is the cyclic integral of the heat is exactly equal to the cyclic integral of work. The meaning is heat and work are mutually convertible with each other, means Q is equal to W. But there is a main disadvantage is Q is equal to W. It is not applicable. It is not applied in actual practice. So let us start with the limitation of the first law of the thermodynamics. Again, you just take example of the rod which is heated by one end. In that particular case, we can say that the heat is transferred from the high temperature body to low temperature body. But after equilibrium condition, we never say that the heat is always transferred from high temperature body to low, from the high temperature body to the low temperature body, or from the low temperature body to high temperature body. So in case of that equilibrium condition, there is no transfer of the heat. So this particular law fails here. So from the first law of thermodynamics, heat lost and heat gain must be equal in the both process. But in actual practice, it is not possible. So the value of the Q is not equivalent with the value of the W. The second law of thermodynamics is related with the concept of the entropy and the energy transformation. So here there are two statements of the second law of thermodynamics. The first is Kelvin-Planck statement and second one is Clausius statement. The Kelvin-Planck statements deal with the concept of the heat engine, but that Clausius statement is related with the concept of the heat engine, not a heat engine, but it deals with the concept of the heat pump, refrigerator and air conditioner. So let us start with the statement of the Kelvin-Planck. According to that Kelvin-Planck statement, it is impossible to construct an engine working in a cyclic process whose sole purpose is to convert all amount of heat into equivalent amount of work with a single thermal reservoir. I repeat once again, it is impossible to construct a device like heat engine working in a cyclic process whose sole purpose is to convert all amount of heat into equivalent amount of work with a single thermal reservoir. Means with the help of only one reservoir we never produce and work. The meaning is for satisfactory operation of that heat engine we always need two reservoirs in order to produce and work. Out of them, one reservoir is related with the high temperature and second one is related with the low temperature. So what exactly that heat engine do in this particular case? So the heat engine absorb Q amount of the heat from the source and simultaneously it will produce and work which is W, and simultaneously some amount of the heat is dissipated to the reservoir which is having lower temperature region. Then it is possible to produce work which is equivalent with W is equal to QH minus QL. So this is the work done of the Kelvin-Planck statement and that particular heat engine, and that efficiency of that heat engine is calculated by the concept of that work done upon heat supplied. Means the formula is QH minus QL upon QH. So this is the efficiency of the heat engine. But when we talk about the Clausius statement, it deals with the concept of the heat pump and refrigerator. We know that the main function of the refrigerator is to maintain the temperature below atmosphere as compared with the surrounding, and the concept of the heat pump is exactly opposite to that refrigerator. But the component used in the heat pump and that air conditioner or the refrigerator are same. Only arrangement of the component is totally different. So in that particular case, the statement of the Clausius is it is impossible to construct a device like heat pump or refrigerator working in a cyclic process in which the heat transfer takes place from the lower temperature body to higher temperature body without add-on of external agency. I repeat once again, the Clausius statement states that it is impossible to construct a device like heat pump or refrigerator in which heat transfer takes place from lower temperature region to higher temperature region without add-on of external work. The meaning is if you never add external work to that device, it is not possible to transfer the heat from sink to source, that is low temperature region to high temperature region. So in order to produce that refrigerant effect, we must have to provide work input to that device, then and then only possible to transfer the heat from the sink to the source. The performance of that refrigerator or heat pump or air conditioner is calculated by calculation of the COP, coefficient of performance. In case of the refrigerator and air conditioner, the COP is equal to refrigerant effect upon work input. But in case of the heat pump, again the formula is same, the heating effect upon work input to that particular device. The third law of the thermodynamics is deals with the absolute zero temperature. So the third law of thermodynamics states as the follows regarding the properties of the closed system in the thermodynamic equilibrium. The entropy of a system approaches a constant values as its temperature approaches to absolute zero. The meaning is the entropy of a pure crystalline substance at absolute zero is zero. This constant value cannot depend on any other parameter characterizing the closed system such as pressure or applied magnetic field. At absolute zero, that is 0 Kelvin temperature, the system must be in the state with the minimum possible energy. So this is the third law of thermodynamics. Now we will discuss the various laws related with the gas. The first law of gas is Boyle's law. So Boyle's law deals with the concept of the temperature. So in case of that Boyle's law, the temperature remains constant, and the Boyle's law states that at constant temperature, volume is inversely proportional to the pressure. I repeat once again, the Boyle's law states that at constant temperature, the volume is inversely proportional to the pressure, and vice versa. The second law, which is related with the gas, is Charles' law. The law states that at constant pressure, the volume is directly proportional to the temperature. I repeat once again, the Charles' law states that at constant pressure, the volume is directly proportional to the temperature. The third most important law, which is related with the gas, but here I forget to mention the name, the Gay-Lussac law. The law states that the pressure is directly proportional to the temperature at a constant volume. I repeat once again, the statement of the Gay-Lussac law is the pressure is directly proportional to the temperature at a constant volume. The fourth law is related with the Avogadro law. The law states that the volume is directly proportional to the moles at a constant temperature and pressure. So when we combine all three laws like Boyle's law, Charles' law and Avogadro law, we will get the equation of that ideal gas. PV is equal to nRT. So now these are some important formulae. It will definitely help you while solving the numericals related with the applied thermodynamics. So the first law is Boyle's law. The equation formula is P1 V1 is equal to P2 V2. The second one is Charles' law. V1 upon T1 is equal to V2 upon T2. The third is Gay-Lussac's law. P1 upon T1 is equal to P2 upon T2. When we combine these laws, then we will get the equation P1 V1 upon T1 is equal to P2 V2 upon T2. And the standard equation of the ideal gas is PV is equal to nRT. So students, these are some important laws related with the thermodynamics as well as related with the gas concepts. So you must have to know these laws before starting the concept of the applied thermodynamics. So you need these all concepts while studying that applied thermodynamic concepts. Thank you.